In this video, I'd like to talk a little bit about uncertainty in measurement. And it's very, very important you look at the limitations of the measuring instruments that you're using and have that reflected in your recordings in class, in a lab, whatever environment you're working on, because there's always some uncertainty. Instruments are only good to certain places. If you notice here, I have, let's start with just a couple of graduated cylinders to start our discussion. And as you come across here, remember with a meniscus, you always read kind of the apex of the curve. So let me bring that one across, and then let me kind of bring this one across as well. And again, so as I read this, that's where I'm going to read to. So that's the point I'm reading. But let's look at our device here. This one is marked 9, 10, 11. I'm going to assume those are milliliters. And in between 9 and 10, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So this is clearly marked to the 10th of a milliliter. My line is between the 9.8 and the 9.9. So I know for certain that my volume is greater than 9.8, and I know for certain it's less than 9.9. So it's somewhere in between. So as I record that, what I'm going to do is I'm going to estimate to the hundredths place, because I know the tenths place. I know it is more than 9.8, and I know it is less than 9.9. So when I record this, I'm going to say it's 9.8 something. In my case, I don't know, I'm going to say 4. Maybe you think 3. That's okay, because here's what you need to know. The last place is always estimated. This is known. This is known. I know it's more than 9.8. I know it's less than 9.9, but I'm estimating this. So known, and this last one is estimated. The last place is always understood to be estimated, even if it's an electronic device. If you read this off an electronic instrument of some sort, the last place on the electronic device is understood to be an estimated position as well. So look at this next one. It's marked 23, 24, and I've got 10 lines in between, so it seems to be more than 23.1 and less than 23.2. So I would record this as 23.1 something. I'm thinking maybe it's a third of the way, so I might call that 23.13. Maybe you would think it's 23.12, 14. That's fine, because we are estimating that last place, and that is completely fine. So know that that last place is estimated. But I am certain it's more than 23.1 because my instrument is marked there. So that's really what we're doing. Let's look at these. These are some more graduated cylinders. This is marked 50, 60. So that means this is 51, 52, 53, 54. So it's marked every 1. So what place should I go to? I should go to the tenths place. Again, you're going one place more than the instrument is marked. So right now that looks to be on the 56 line, but here's what you need to recognize. You don't write 56. You have to write 56.0, so whoever is reading this knows that you were able to estimate that place. It is marked to the tens, it is marked to every 1, so we must estimate the tenths place. Even if it's right on the line, you still want to do that. Look at this next one. And by the way, notice I'm also including my units here. Always include your units when you're doing measurements. So we have 3, 4. I have 10 lines in between. So this is the 4.3. This is the 4.4. So to me, it seems to be between those two places. So I'm going to call this 4.3 something. To me, it looks a little less than halfway. So I'd call that 4.34 milliliters. Again, the 4 is estimated at the end here. Perhaps you would put it as something else, and that is certainly fine. But it is definitely more than 4.3, definitely less than 4.4. Now, here is the first trick that comes up. Here is 4, here is 5, but I don't have 10 spaces in between. I only have 5 spaces. So this is not marked every tenths. It's marked every other tenth. So this is like 4.2, 4.4, and so forth. So my line here, this is 5.2, this is 5.4. Here's the problem. Since it's not marked to every tenths, I can't go past the tenths place. It has to be marked to every place for you to go one place past it. So really the best I can do here, clearly it's more than 5. It's between the 5.2 and 5.4 line, so I'm just going to call that 5.3. But the key thing you need to recognize is that since it is not marked, here we were marked every tenths, so we could estimate the hundredths. Here we are not marked every tenth, so we can't go beyond that place. Here's another example. These are thermometers. I'm going to assume these are in degrees C. So here is 65, 66, 67, 68. So I would write 68. To me, it looks like it is right on the line. So I'm going to go to the tenths place and say 68.0. Again, why am I going to the tenths place? Because it is definitely marked every one, so I can estimate the tenths. And you should. You always should go one place beyond what it's marked. Here is 0. Here's -5, -10. Here's, -1, -2. So it's marked every one. So to me, this is between -2 and -3. It's between those two lines. So I'm going to call that negative, I don't know, I'll say 2.8. But again, you may disagree with the 8, and that is certainly fine, but it is clearly less than the -2 line and definitely a little above that -3 line. So it's between those two numbers. And then for this last one, again, this is kind of like what we talked about over here. Notice that this is marked 0, 10, 20, but it's not marked to every one. This is 12, 14, 16, 18. So to me, it looks like it's on the 16 line, but since we're not marked to every one, I can't go past the ones place. So I'd mark that just as 16 degrees C. Now coming over here in the bottom left, you've got a triple beam balance. These you'll use in class and you'll practice a little bit, but you're going to read your places. This will be 100 for the hundreds place, 0 for the tens place, 9 for the ones place, point. And if you'll notice, this is marked every tenth. In between the tenths, you have 10 lines. So it's actually marked every hundredths place. So it's going to be 109.0. And to me, this looks like it's maybe a little below the 0.08 line. So I'm going to go 0.079. Now again, why am I doing that? Because this represents 0.01, 0.02, 0.03, 0.04, 0.05, and so forth. So notice it is marked every hundredths place. And since to me it looks like it's a little less than the 0.08, or the 0.08 line, I would call it 0.079. So that's how I would do that one. And then for these last two, again, these are just rulers. Obviously, you can see these are marked in centimeters. And so this one, to me, it's marked every 7, 8, 10 lines in between, so it's marked every tenths. So I would go to the hundredths, and I would say maybe 7.75. That's centimeters. Oh, by the way, this one is grams. Don't forget your units. And to me, that looks a little between the lines. Here, this seems to me to be right on the line. But again, since it is marked every tenths, I would go to the hundredths. So I actually have to go 4.00 centimeters because it is marked every tenths, so you must go to the hundredths. So one of the key things I want you to pick up on is you're always going to go one place more than the instrument is marked. Okay, and I think I'm going to do the accuracy and precision in a separate video, so just look for that as a separate video and we'll discuss that topic next.